On the bottom of this page, so just underneath the properties, it asks what properties of whole number multiplication justify these equalities, these equations. So the first one, we have 7 times 3 plus 7 times 8 equals 7 times 3 plus 8. That is the distributive property. That's an example of the distributive property. If you've taken an algebra class, and you all should have taken more than one algebra class, you will have seen this used quite often. The second one, we have 5 times 9 times 11 in parentheses equals 5 times 9 in parentheses times 11. Anytime you're moving your parentheses, you've got the associative property. And the last one, I'm just going to say because it's long to write it, but the last one, 1 times 12 is 12. That's the multiplicative identity property of 1. That is a mouthful. Multiplicative identity property of 1. Now, on the next page, I've got a couple examples. I actually want to jump to the second one here because it's dealing with those properties again. And I want to show you how we can use those properties to make it a little easier on ourselves to do mental math. For the first one, we have 7 times 16 plus 24 times 7. And for many people, they're not able to, at least quickly, multiply 7 times 16 in their heads or 7 times 24 just in their heads. But using some of those properties, we can rewrite this. So using the commutative property, the second one, 24 times 7, you can just change the order. So you could write this as 7 times 16 plus 7 times 24. And then you could use the distributive property to rewrite this. You could do 7 times 16 plus 24. Well, 16 plus 24 is 40. So what you're looking at here is just 7 times 40. And that is easy to do in your head, 280. And a lot of times if you see people that are able to do arithmetic in their heads, they're doing these types of changes using those properties. They're not writing it down, they're doing it all in their head. But this is how they're doing it. They're taking these mental shortcuts. For the second one, we have 23 times 25 times 35 times 24 times 0 in parentheses. And really the trick here is seeing that zero. If you wanted to, you could use the associative property and move the parentheses so you have 23 times 25 times 35 times 24 in the parentheses and then the whole thing times 0. And using multiplication by 0, it doesn't matter what 23 times 25 times 35 times 24 equals. When you multiply it by 0, you get 0. Now, the last one is probably the trickiest at first glance. This one, you're going to have to break it down and build it back up in a sense. You have 36 times 15 plus 12 times 55. And there might be some of you saying, well, I can just pull out the calculator on my phone and work this. Why do I need to learn these mental calculations? You know, there's the tried and true. We don't always have our phones. There are circumstances where we don't. But what I would posit is even more important than that is sometimes it's good to think things through. If we go to our phones all the time for things, we can lose our critical thinking abilities. And that's a shame to see. So sometimes it's good to try to think things through, logic things out on our own. So that's what I'm going to do with you here. So what we're going to do, like I mentioned a moment ago, we're going to break this down and then kind of build it back up. I'm going to take the 36 and rewrite it. 36 is 12 times 3. So instead of 36, I have 12 times 3 times 15 plus 12 times 55. Now, using the associative property, I'm going to move the parentheses here for my first term. So I'm going to rewrite this as 12 times 3 times 15 plus 12 times 55. And 3 times 15 is 45. So we have 12 times 45 plus 12 times 55. Using the distributive property, I can now write 12 times 45 plus 55. 45 plus 55 is 100, so what we have here is 12 times 100, or 1,200, 1,200. So again, just using these properties of multiplication to calculate these products and sums mentally. Now, I'm going to skip back up to the top of the page. Boop, boop, boop. And we are going to use rectangles and rectangular areas to show that these statements are true. So these statements are highlighting some of the properties of multiplication. And in a classroom, you could use the tiles to show these, but here I'm going to draw them out. So my squares are not going to be perfect, but hopefully they'll give you a good idea of how you could use tiles for these. And you might want to use 2 different colors of tiles. So for the first one, we're going to demonstrate that 2 plus 5 times 3 is the same thing as 2 times 3 plus 5 times 3. So what you can do is make a rectangle that's 2 plus 5, so 7 on one side and then 3 on the other. And what I would recommend doing if you're using tiles is do some of them in one color. And again, you can see mine are getting bigger as we go. If you're using real tiles, of course, they're all going to be the same size. And then represent the 5 with the second color. So here we have a 7 by 3 rectangle. And if you were to, take the red tiles and move them slightly to the left and the blue tiles and move them slightly to the right, you can see that it's comprised of 2 rectangles, a 2 by 3 rectangle, there's our 2 times 3, and then a 5 by 3 rectangle, there's our blue one. So again, just using those tiles to show these properties of multiplication. For this second one here, we're showing 3 plus 2 in parentheses times 4 plus 3, also in parentheses, is equal to 3 times 4 plus 3 times 3 plus 2 times 4 plus 2 times 3. If you remember the foiling from algebra class, if you had something like this, x plus 1 times x minus 3, and when you would multiply it out, that's actually what we're showing here. This is just an early introduction to that. And I would do something very similar, except here I would use 4 different colors. So I've got my 3 by 2. So let me do the 3 part, okay? I'll do the 2 here in red. Okay. And then we need to take that times a 4 plus 3. Okay, so my one side is 3 plus 2. The other side is going to be 4 plus 3. So you're going to see me change colors again. So here's the 4 parts. So very similar to the previous one right now. So I have a 3 by 2, or 3 plus 2 by 4. And you can see again, you could separate this out. But now I need to deal with this plus 3 in that second set of parentheses. So I'm going to go to 2 different colors. Let's do some orange here. So I have a rectangle that's 3 plus 2 on one side, 4 plus 3 on the other. And if you break these apart into the 4 different colors, you have your 3 times 4, 3 times 3, 2 times 4, and 2 times 3 demonstrated. So again, able to use manipulatives to show how these multiplication properties work in real life.